हेलो फ्रेंड्स, आज हम देखेंगे equal sets. So what is mean by equal sets, and when we say that the two sets are equal, let's understand. Now suppose there are two sets, set A and set B. So if every element of set A is in set B and every element of set B is in set A, then we can say that set A and B are equal sets. Let's understand with an example. And if the sets are equal, we write as A equal to B. So this is how we can write the equal sets, A equal to B. We use equal sign to denote that the two sets are equal. And we have already studied that the sets are denoted by capital letters like A, capital B, capital C, etc. So let's take an example. Suppose we have set C and set D. So suppose set C has 4 elements, 6, 7, 8 and 9. And D has elements 9, 6, 8 and 9, 6, 8 and 7. So there are 4 elements in set C. And D also has 4 elements. But let's check whether the elements are same or not. So we have in set C we have 6, 7, 8 and 9. So we will check whether D also contain the same element. So 6 is here, this is 6, then 7, then 8 and last 9. So elements are same. So we say set C is equal to set D. So the both sets are equal. And we already studied that set C, when we write elements in set, their order is not important. So here in set C, there is first element is 6, then 7, then 8 and then 9. So first C 6, then 7, then 8 and then 9. So this is the order of these elements. But in set C we have different order, that is it first is 9, then 6, then 8 and 7. So here in this set order is not the same, but we have already studied that the order is not important while writing the set. So we say set C and set D are equal sets. Now let's take another example. So we have two sets, set E and set F. So in set F there are 3 elements, 98, 99 and 100. So we will check whether these same elements are also in set E. So we have 98, then 99 and then 100. So elements are same. So we say set E and set EF are equal. Let's take another example. Here we have set C, set X and set Y. In X we have two elements, -5, 5. So two elements. In Y there are also same elements, that is -5 and 5. So the elements are same. So we say set X is equal to set Y. Let's take another example. So we have two sets here again, set P and set T. So in set C, in set P we have 3 elements, -1, 0 and 1. In set T also we have -1, 0 and 1. So elements in both the sets are same. So we say set P is equal to set T. So this way we can check whether the two given sets are equal or not. Now let's see, next topic is Venn diagram. So what is mean by Venn diagram? So when we say Venn diagrams are the figures which are expressed to show the set. So let's understand. So in Venn diagram, closed figures are used to represent sets. So in what is mean by closed figures? Closed figures means if this is a figure, this we can say this is not a closed figure. Why? Because the interior part is not completely separate. Now if we complete this way, so then this figure will become closed figure. Let's take another example. So we have here circle, but circle is not complete, so we say this is not a closed figure. And now if we complete this circle, then we say this is a closed figure. Let's take another example. Now we have some figure like this. So this is not a closed figure, and if we complete both the ends and the interior part is completely visible, then we say this figure is a closed figure. So this way we can first identify whether the figure is closed or not. Now we use such a Venn diagrams to understand, illustrate and solve examples based on sets. So let's understand with an example. So let's take we have a set A. We have set A which has 4 elements. So 1, 2, 3 and 4. So elements 8, set 8A has 4 elements 1, 2, 3 and 4. So let's represent this set by Venn diagram. So let's in this figure we will write set A. We know that capital letter is used to represent set. So we have set A and we will write the elements 1, 2, 3 and 4. So this is the Venn diagram of set A. Or we can use another figure like this. So this is an next closed figure. Now we can write a set A in this figure. So set A, we will write capital letter and write the elements 1, 2, 3 and 4. So this way we can also show the set A, or we can also represent in this figure. So we have set A and we will write the elements 1, 2, 3 and 4. So this is the also representation of a set A by using Venn diagram. Or we can also use this figure. So we will write A and we will write 1, 2, 3 and 4. So all the elements are shown also here. Or we can use this figure also. This is a rectangle. We will write capital letter A and we will write elements 1, 2, 3 and 4. So while in set, generally we use rectangle to show the universal set. So what is meant by universal set? We will understand this in next point. So for this time being, this is what we understand by Venn diagram. So Venn diagrams are the closed figures which are used to represent a set. So this way we can show any set in by using Venn diagram. Now let's see what is meant by subset. So we already studied what is meant by set, then so we have already learned what is meant by set and how Venn diagrams are used to represent set. Now let's see what is meant by subset. So subset, if A and B are two given sets and every element of set B is also an element of set A, then we say B is a subset of A. That is, every element of set B is also in set A, then we say B is a subset of A, and this is written as B is subset of A. This is how we can represent subset. B is subset of A. So this way we can represent subset. Now let's understand with an example. So we have two sets here, set A and set B. So in set A there are 8 elements and set B there are 4 elements. So by Venn diagram we will represent this set like this. So we will use right here, this is set A. So elements of these sets are 1 to 8. But first write the elements of B. So set B has 2, 4, 6, 8. These 4 elements are under the set B. So we'll write 2, 4, sorry, comma is not included in this Venn diagrams. So we will erase this. So first write capital set B. So there are 4 elements, 2, 4, 6 and 8. And rest of the elements of set A we will write in this rectangle. So we have 1, then 3, 5, 6 is already there, so 7, 8 is already in B, and then 9, so sorry 9 is not there, so up to 7. So this is how we can represent, and this is a rectangle, is a set A. So this rectangular set A contains all the elements 1 to 8, and a B is a subset of that set, and it contains 4 elements 2, 4, 6, 8. So this is how we can represent subset by using Venn diagrams. Now regarding subset and set, we need to remember some point. So first point is every set is a subset of itself. For example, if set A is a set, then it is a subset of itself. Let's take another example. So if there is a set B, then it is also a subset of set B. We represent subset by this symbol. So this is the representation of subset. And how we read? B is a subset of B. Then if Z is a subset, Z is a set, then subset of Z is a Z itself. Then if D is a set, then it is also a subset of D. So this is how we can remember that every subset is a subset, every set is a subset of itself. Then next point is to remember is empty set is a subset of every set. So phi is represented as empty set. So empty set phi is a subset of D. Let's take another example, and how we write this by using notation. So phi is subset of D. Let's take another set. Suppose we have set C, then it is also empty set is also subset of C. Let's take another set. So if we have set P, then phi is also an subset of P. So this way we can represent empty set. Next point to remember is if A is equal to B, then A is a subset of B and B is subset of A. This is how both the equal sets are considered. That is, if A is equal to B, then A is a subset of B and B is subset of A. By notation we can write this way. If A equal to B, then A is a subset of B and B is subset of A. So this is how the third point is. And the last point is actually the converse of the third point. That is, if A is a subset of B and B is subset of A, then A is equal to B. So this is actually the converse of this third point. So while dealing with set and subset, we need to remember these 4 points.